using intercepts, these techniques that you're going to go through are going to help you understand and describe what you're graphing more clearly. And as we talked about intercepts, where a line intersects a specific location, and that's an axis. Now, we've got two intercepts that we're going to talk about, the x or possibly the y. And we got through and defined them here. The x-intercept is where you cross the x-axis, which you can see from here is at this location. And notice that when you find the x-intercept, y is always going to be 0 because you don't go up or down. If you went up or down, you'd no longer be sitting on the x-axis. In contrast, the y-intercept is where your graph crosses and touches the y-axis. And when you find the y-intercept, x is always 0. Now, that being said, this is probably one of the most confusing things for people because they mix up what is what. Okay, your right-left is always x, your up-down is always y. The first term being the domain, x value. Second term being the range, the y value. Okay, this definition is in your book on page 398 in case you don't have this with you later. And we're going to use that to solve for these locations. In example 1, they say find the intercepts. Okay, find the intercepts. And they give you an equation, 3x minus 2y is 6. Okay? So in order to find the x-intercept, y is what? Y equals what?
0.
Always equals 0, okay? That was that first thing I shared with you. To find the x-intercept, y must be 0. So if I make that 0, I can solve for the value of x when y is 0. By doing that, I have found the intercept. So, 3x minus 2 times 0 equals 6. So 2 times 0 is 0. 3x minus 0 is 6. 3x is 6, right? Because the 0 is irrelevant at this point. Divide by 3, and what's the value for x? Therefore, of this graph, the x-intercept is 2, 0. You can't just say 2. I mean you could, but the normal, well, they do describe it that way, but normally you're going to give the entire coordinate pair. But if they ask you to identify, I guess at this level, they just ask for that. If you give me this, I'll be happier. Okay? Same equation, only they want the y-intercept. So if you are looking for the y-intercept, x must equal what? Awesome. Okay, when I'm looking for the y-intercept, x must equal 0. So we're going to use that same equation, 3x minus 2y is 6. Only instead of having x as a value we're searching for, it's a 0. Okay? Looks something like that. When we solve for y, the y value is where it crosses the y-axis. So 0 minus 2y is 6, so that means negative 2y is 6. Divide to solve for y, and looks like y is negative 3. Okay? Therefore, the y-intercept is found at 0, negative 3. Negative 3 being where we cross the y-intercept. Okay? How are you guys feeling about this? All right. Let's go ahead and move on to example 2 then. Whoopsie, wrong way. If you are given information like an equation, you can actually graph the equation without solving for points. And this is super, super cool. Some of you, you're going to love this. Some of you, you're going to be baffled by it. Either way, find a way to get this, because this is a very, very easy little trick. If I want to graph something, up to this point, you guys have solved for a few examples, right? Well, what if we graph using intercepts? That means find out what x is at 0, and find out what y. Find the values when x is 0 and when y is 0. By doing that, you are finding your intercepts. Okay, here's what I mean. The equation they give us is 3x minus 2y is 6, the one we used above, right? The one we used in example 1. We already found that the intercept point for x is negative 2, 0. I'm just going to rewrite that real quick. Negative 2, 0. This was the x-intercept. And the y-intercept was 0, negative 3. Okay, guys, I'm just kind of continuing where we were on the previous page. Okay, I found out, thank you, I found out that when y is 0, x is 2, and I found out when x is 0, y is negative 3 by plugging in. So if I graph these 2 points, I'm going to have a graph that looks something like this. I'm only going to graph the right-hand side. Over 2, up 0, and over 0, down negative 3. Do you see how I'm just kind of cheaply labeling this? I'm not labeling every single line. That's okay as long as you have the right points. Connecting these 2 points is the graph of 3x minus 2y is 6. Okay? I used my intercepts that I had already done in example 1, and I graphed. Let's do checkpoint 1. Okay? Checkpoint 1, the more you practice this, the easier it's going to get. And I highly recommend you do it the way I'm showing you. X minus 2y is negative 2. Okay, checkpoint 1 says find the intercepts and graph it. Everybody's copying their notes, right? Find the intercepts and graph it. So if I make x 0, then I end up with 0 minus 2y is negative 2. Divide by negative 2, y equals 1. Would you agree with me? Okay. One times negative 2 is negative 2, right? Okay. So here, this particular item, when I made x 0, solved for my y-intercept. Okay? If I make y 0, I'm solving for my x-intercept. X minus 2 times 0 is negative 2. Obviously that's 0. That becomes a 0. Because 2 times 0 is 0. X equals negative 2. I have just solved for my x-intercept. Okay? Where x is 0, y is 1. That's my y-intercept. where y is 0, x is negative 2. That's my x-intercept. There's 0, up 1. All right. So I need the left side of my graph. Yes? Oh, my word. Flying all over the place. All right. Thank you, ma'am. So to graph this point, over 0, up 1. Okay? Right, left, 0, up 1. Okay? That's this point. To graph this point, left negative 2, up 0. Okay? There's my points. Connect it. Okay? So here's my equation. Plug in a value for 0, x, solved for y. Got my first set of points. Here's my second equation. Copied it again, plugged in y at 0, solved for x, graphed my line. Okay? Let's do example 3, checkpoint 3. Same thing. Find your intercepts and graph. Y equals 2x minus 8. Okay? If I make x 0, I have y equals 2 times 0, which is 0, negative 8. Right? Y equals 2 times 0 minus 8. Okay? So that means y is negative 8. Okay? Where x is 0, you have a y-intercept. Now, let's make y 0. 0 equals 2x minus 8. I just made my y 0, just like up there, I made my x 0. What do I do now? What do I do now? Go ahead. Add 8. Because you want numbers on one side and a variable on the other. Now you can solve it. Some of you might have already known that 2 times 4 minus 8 is 0. But if you didn't see it, that's how you do it. Whenever you have 0 on side and letters and numbers on the other side, you move one thing over. Okay? So if x is 4, okay, which leads me to this. Now you could also graph this by 2's, since these are both multiples of 2. So over 0 down negative 8. 1, 2, 3, 4, 5, 6, 7, 8. Wow, should have just graphed it by 2's. Okay, there's 0, negative 8. There's 0, negative 8. Over 4 up 0. 1, 2, 3, 4. 4, 0. Okay? Connect the line. You can't just graph the dots. Connect the line. Because you're showing that this entire equation could be solved at multiple points as long as you found them along the line. Okay? These are not the only two solutions for that. All right. Writing and graphing an equation. This is the last thing we're going to do for today. Writing and graphing an equation. You might not realize this, but what you're learning about right now is something called, well, it's a linear equation. I'll just leave it at that. You can solve a lot of things with this type of thinking. Pay attention. You're canoeing a 12-mile stretch along the river. You go 4 miles per hour paddling and 2 miles per hour drifting. You must be going with the current. So 4 miles per hour paddling and 2 miles per hour drifting. Write an equation and graph it describing your possible paddling and drifting times for the trip, and give 3 possible combinations. Okay, so the equation they give us is 4 multiplied by the amount of time I spend paddling, combined with 2 multiplied by the time I spend drifting. Any combination of those that equal the 12 miles you have to cover is going to be correct. Okay? I would find the intercepts. That's what I would do. I would find the intercepts. To start with, anyway. Because they want 3 combinations, don't they? Give 3 possibilities. Okay, so if y is 0, that means 4x plus 2 times 0 is 12. 4x is 12. So x is 3. Okay, so if I paddle for 3 whole hours non-stop, I'll make the distance. In contrast, if I don't paddle at all, and I just drift, it looks something like this. Okay? So far I know I can do it 3 hours paddling and no drifting, or 6 hours drifting and no paddling. How about a third scenario? Let's make x1. 4 times 1 plus 2y is 12. And I picked 1 because I know 12 is a multiple of 4. Okay? So now I have 4 plus 2y is 12. And I also like small numbers. How about if I subtract 4? I have 2y equals 8, right? Y must equal what? 4. So simply by adding some paddling, only 1 hour, I've come up with a third scenario. Let's just graph my intercepts though. 3, 0, and 0, 6. Over 3 up 0, over 0 up 6. 1, 2, 3, 4, 5, 6. Okay, those are the 2 intercepts. Would 1, 4 fit on this line? Let's check. And it won't go below here because you're not going to have any negative. Over 1, up 1, 2, 3, 4. Okay, those are the 3 points that indicate possibilities. I would say it looks like 2, 2 is close too, right? 4 times 2 is 8. 2, 2. 4 times 2 is 8. 2 times 2 is 4. 8 and 4 is 12. Okay? These are the scenarios with which you can accomplish your paddling and your drifting effectively. And by solving it, setting it up at one rate times a specific way of movement, added to another rate times a specific way of movement, you have your answer.